Okay, we're going to solve using solve by using algebra. And the zero property. So let's try this problem. We'll do a couple problems. So we will do 3x squared plus 4 equals 0. Again, you want to get the quadratic term to be isolated. So we want to move the 4 over to the other side. And that gives you 3x squared. Don't forget, when you move something over to the other side, you've got to change the sign, so that becomes negative 4. You can't use the square root property yet because the coefficient has to be 1, so you got to divide out that 3 first. And that leaves you with x squared equals negative 4/3. Okay, now you can use the square root property, and you can take the square root of both sides. Don't forget, when you use the square root property, you got to remember that's right, the plus and minus. Don't forget that. And so we think we have the answer. The problem is that we can't leave this radical unsimplified. So off to the side of our paper, we need to simplify this radical. So remember, you learned back in maybe geometry or algebra 1 that if you have the square root of a fraction, you can rewrite it as the square root of the numerator and as the square root of the denominator. If we go ahead and simplify the numerator, remember we talked about taking the square root of a negative number, so the square root of negative 4 is going to be 2i. And then we're just going to recopy the denominator. Well, we're not done yet because you're not allowed to have a radical in the denominator, so we have to do what's called rationalizing the denominator. So we're going to multiply by the square root of 3 over the square root of 3. Because really that is just a magic number 1. When we multiply by that, let's see what happens. So how do you multiply fractions? Don't you multiply the numerator straight across? So that gives you 2i times the square root of 3. And then don't you multiply the denominator straight across? So that gives you square root of 3 times 3 is square root 9. And then isn't the square root of 9 just 3? So let's see if we are done. Are there any pairs hiding underneath the radical? Is there a radical in the denominator? If you can simplify this and reduce it, you must. Now you can't reduce these two because this is under the radical and this is not, so you cannot reduce those. But if you could, you might be able to reduce those. In this problem, it's unreducible. So now we're okay because there's no pairs hiding, there's no radical in the denominator, and there's nothing for us to reduce. So we have our final answer. Don't forget, when you write your final answer, you've got your plus and minus. Can't leave that out of your answer. And you have 2 imaginary roots. Remember, we were looking for the x-intercepts. So when you get imaginary numbers, that means the parabola will have no x-intercepts. They have 2 imaginary roots, but they have no real roots. We'll talk a little bit more about that vocabulary on Monday. Okay, so this is your final answer. And here we just took a little bit of extra time just to describe these roots. So these roots are 2 imaginary roots, and that's because the parabola does not have any x-intercepts. So you could say 2 real roots, or you could say no real roots. So 2 imaginary roots or no real roots. Okay, let's try another one. Okay, how about 2x squared minus 27 equals 0? Again, we want to isolate the quadratic term, so we're going to move that over to the other side. That gives us 2x squared equals positive 27. We cannot use the square root property yet because we want this, we have to have 1x squared, so we have to divide out the 2, and then we get x squared equals 27 halves. If I could reduce this, I sure would, but since I can't, I'm just going to leave it like that. Then we can use the square root property, and we can undo x being squared by taking the square root of each side. Don't forget, when you use the square root property, you got to remember that's right, plus and minus. So we're not done yet because you can't leave a radical unsimplified. We must simplify that radical. So over here, we will show the work on how to simplify that radical. So remember, you learned that if you have a fraction underneath a radical, you could rewrite it as the square root of 27 divided by the square root of 2. Now there's lots of ways to do this problem, so you might see it differently from different people. But the first thing I'm going to do is I notice there's a pair hiding in there, so I'm going to simplify that radical. So in case you need the extra help, you should have gotten this from geometry. Isn't the square root of 7 9 times 3? And isn't 9 a pair of 3s? So that gives you 3 radical 3, in case you forgot about that. So when you simplify the square root of 27, you get 3 radical 3 over square root 2. So we think that's our answer. So we have no pairs hiding in here, but we're also not allowed to have a radical in the denominator. So now we need to rationalize the denominator. So we're going to rationalize the denominator by multiplying by the square root of 2 over the square root of 2. Remember, that's just a fancy way of writing the number 1. So how do you multiply fractions? You must multiply straight across. So when you multiply this straight across, you get 3 square root, and then 3 times 2 is 6. And there are no pairs hiding in there, so we're good. And then square root of 2 times square root of 2 is square root 4. And of course, as you know, square root of 4 is the whole number 2. That was the whole reason why we did that. Because that little trick of multiplying by the square root of 2 over square root of 2, which is just a fancy way of multiplying by 1, that made the denominator turn into a whole number. You cannot reduce these two because one's underneath the radical and one's not. So let's check it. Do we have any more pairs hiding under the radical? No. Do we have a radical in the denominator? No. Can these two numbers that are outside be reduced? No. Then we know we're done. It's my little happy face. Okay, that's a scary happy face. So here's our final answer. Oh, what did I forget? Yep. Don't forget to write your plus and minus in your final answer. If you leave it out, I have to mark you wrong. So always go back before you finalize your answer. Make sure you didn't leave out that plus and minus. And then what kind of roots do we have here? We have two of them. We have the positive 3 square root 6 over 2. And we have the negative 3 square root 6 over 2. So we have 2. And what types of roots are they? Are they rational, irrational, or imaginary? Yep, they are irrational roots. And bring your calculators on Monday. We'll figure out what that decimal approximation is so that maybe we could graph it. Lots of vocabulary words in this unit. Okay, I'm going to try another one. Let's try one more. Maybe you can pause it and get a step ahead of me. We need to isolate the quadratic term, so we're going to move that over. Got to change the sign, so because we moved it over, it's a positive 10, that's now a negative 10. Got to divide out that coefficient before we use the square root property. Now we can use the square root property because the coefficient's 1. Undo the squaring by taking the square root of both sides. Don't forget, when you use that wonderful square root property, don't forget that plus and minus. Are we done? No. Got to simplify our radical. So, right, we learned that if you have a fraction underneath the radical, you can rewrite it as the square root of the numerator and the square root of the denominator. Do we have any pairs hiding in here? Nope. But we do have the square root of a negative number, so we could simplify that and say I square root 10, because the square root of the negative is going to give us the I. Right? So we have no pairs, so we simplify the radical. Now we can't have a radical in the denominator, so we have to rationalize the denominator. So we're going to multiply by the square root of 3 over the square root of 3. When you multiply the numerator straight across, you get I, and isn't the square root of 3 times square root of 10, that's going to be the square root of 30. Are there any pairs hiding in there? Nope. Oops, eraser. Square root of 3 times square root of 3 is square root 9. And then the square root of 9 is the whole number 3. We'll just recopy the numerator. Now are we done? Let's double check. Are there any pairs hiding underneath the radical? No. Is there a radical in the denominator? No. Can the outside numbers that are outside the radical be reduced? No. Then we know we're done. So the final answer is x equals, don't forget your plus and minus, I square root 30 divided by 3. What kind of roots are those? Are they real rational roots? Are they real irrational roots? Or are they imaginary roots? Yep, they're imaginary. And you have two of them, don't you? You have the positive one and the negative one. So you have two imaginary roots. And the fact that they're imaginary means that if we were to graph that parabola, and I'm just estimating, that just means that our parabola is not going to have any x-intercepts. This is just a general sketch. It's definitely not an accurate sketch. Okay? I hope that helps. Listen to it as often as you need to.